Before you unfolds one of the most grandiose spectacles in the universe, the Milky Way galaxy, our cosmic home. This is a magnificent spiral structure containing between 200 and 400 billion stars, each of which is an entire world with its own history. The Milky Way stretches 100,000 light-years across. To understand this scale, imagine light traveling at 300,000 kilometers per second would take 100,000 years to cross our galaxy from edge to edge. If you could compress all of human history into 1 second, it would take more than 3,000 years of human history to cross the galaxy at the speed of light. The spiral arms of the Milky Way are not static structures, but density waves, similar to traffic jams on a cosmic highway. Stars and gas clouds pass through these arms, temporarily compressing and creating the illusion of permanent structures. 4 major arms, Perseus, Sagittarius Carina, Scutum Centaurus, and Norma, spiral around the center, creating the recognizable spiral pattern. At the very heart of the galaxy lies a supermassive black hole called Sagittarius A star. Its mass exceeds that of our Sun by 4 million times, yet it is compressed into a region smaller than Mercury's orbit. This is a gravitational monster around which the entire galaxy rotates. Stars near this black hole move at mind-boggling speeds. Some accelerate to several percent of the speed of light, orbiting the black hole in just a few years. The central bar of the galaxy is an elongated structure about 27,000 light-years long, consisting predominantly of old yellow and red stars. This bar rotates as a single entity, and it is from its ends that the spiral arms originate. Interestingly, astronomers discovered this structure relatively recently, only in the early 2000s, observing the galaxy in the infrared range, which allows penetration through cosmic dust. Our Sun is located approximately 26,000 light-years from the galactic center, in a small branch called the Orion Arm or Orion Spur. We are not in a major spiral arm, but in an intermediate structure between the Perseus and Sagittarius Carina arms. The Sun orbits around the galactic center at a speed of about 230 kilometers per second, completing a full revolution in approximately 225 million years. This means that since the time when dinosaurs ruled the Earth, our solar system has completed only 1 galactic year. Star formation in the Milky Way occurs predominantly in the spiral arms, where giant molecular clouds compress under the influence of gravity. The Orion Nebula, visible to the naked eye as a fuzzy patch in the constellation Orion, is only 1,300 light-years away from us and is the nearest major star factory. Inside this nebula, thousands of new stars are being born, many of which are surrounded by protoplanetary disks, future planetary systems. Dust plays a critical role in galactic ecology. The dark bands crossing the Milky Way are not empty regions of space, but dense clouds of dust and gas blocking the light of stars behind them. These clouds consist mainly of molecular hydrogen, at temperatures of only 10 to 20 degrees above absolute zero. It is in these cold, dark regions that new stars form. Paradoxically, the coldest places in the galaxy are the cradles of the hottest objects. Young stars. Globular clusters are the most ancient inhabitants of our galaxy. These spherical collections of hundreds of thousands or even millions of stars formed more than 12 billion years ago, when the galaxy was just beginning its existence. The Milky Way contains about 150 known globular clusters, though there may be significantly more. In the center of such clusters, stars are located so densely that the distance between them is only a few light weeks, millions of times less than the distance to the nearest star to us. If we lived on a planet inside a globular cluster, the night sky would shine with thousands of bright stars, and true darkness would never come. Open star clusters, in contrast, are young and located in the galactic disk. The Pleiades, or Seven Sisters, is the most famous such cluster, visible to the naked eye. These stars are only about 100 million years old, infants by cosmic standards. They were born from one cloud of gas and dust and are still traveling together through space, though over time, gravitational interactions will disperse them. Nebulae are some of the most beautiful objects in the galaxy. Emission nebulae, such as the Lagoon Nebula or the Carina Nebula, glow with red and pink light due to ionized hydrogen. Massive young stars inside these nebulae emit intense ultraviolet radiation, which makes the surrounding gas glow like a cosmic neon sign. The brightest star-forming region in our part of the universe is the Tarantula Nebula in the Large Magellanic Cloud, a satellite galaxy of the Milky Way. If this nebula were located at the distance of the Orion Nebula, it would illuminate our planet brightly enough to cast shadows at night. Planetary nebulae are the dying gasps of stars similar to our Sun. Despite the name, they have nothing to do with planets. They were so named by early astronomers because of their disk-like appearance in primitive telescopes. When a medium-sized star exhausts its fuel, it sheds its outer layers, creating an expanding shell of glowing gas. The central star transforms into a white dwarf, an incredibly dense remnant about the size of Earth, but containing mass comparable to the Sun. A teaspoon of white dwarf material would weigh several tons on Earth. Supernova remnants are fascinating monuments to the violent death of massive stars. When a star with a mass of more than 8 solar masses exhausts its fuel, its core collapses in fractions of a second, releasing energy equivalent to the explosion of an octillion nuclear bombs. The shockwave destroys the star, scattering its heavy element-enriched matter into space. The Crab Nebula is the remnant of a supernova observed by Chinese astronomers in 1054. At its center is a pulsar, a neutron star only 20 kilometers in diameter, rotating 30 times per second, with precision exceeding atomic clocks. Neutron stars are among the most extreme objects in the universe. They are so dense that protons and electrons merge, forming neutrons, hence the name. A teaspoon of neutron star material would weigh 1 billion tons. The gravity on the surface of a neutron star is 200 billion times stronger than Earth's. If you somehow dropped an object from a height of 1 meter above a neutron star, it would hit the surface at a speed of 7 million kilometers per hour. Magnetars are neutron stars with magnetic fields hundreds of trillions of times stronger than Earth's. These are the most powerful magnets in the universe. A magnetar's magnetic field is so intense that at a distance of 1,000 kilometers, it could tear a human body apart at the atomic level, literally distorting the electron clouds of atoms. Magnetar flares, caused by starquakes, can release more energy in fractions of a second than the Sun emits in 1,000 years. Stellar mass black holes are scattered throughout the galaxy, perhaps from 10 to 100 million such objects. Most of them are invisible and solitary quietly drifting in interstellar space. However, when a black hole is in a binary system with a companion star, it can pull material from that star. Gas spirals into an accretion disk around the black hole, heating to millions of degrees and emitting powerful X-rays. Cygnus X1, the first serious black hole candidate, contains an object with a mass of about 15 suns, compressed to a point of no return. Dark matter is the invisible substance that makes up about 85% of all matter in the galaxy. We cannot see it directly, but its gravitational influence is obvious. It is dark matter that prevents the Milky Way from flying apart at high rotation speeds. The galaxy is immersed in a giant halo of dark matter, extending about 600,000 light-years from the center, much farther than the visible stars. The nature of dark matter remains one of the greatest unsolved mysteries in physics. The stellar halo of the Milky Way is populated by ancient stars with low heavy element content, known as population II stars. These stars formed more than 10 billion years ago, when the galaxy was young. Many of them came from dwarf galaxies that the Milky Way absorbed throughout its history. Stellar streams, long strings of stars wrapping around the galaxy, are the remains of such tidally disrupted galaxies, a kind of galactic fossils. The Sagittarius dwarf elliptical galaxy is currently being devoured by the Milky Way. This small galaxy has already passed through our galaxy's disk several times, and each passage tears more stars from it. Its stars now form loops around the Milky Way, gradually merging with our stellar population. In a few billion years, nothing will remain of Sagittarius. It will be completely assimilated. The Large and Small Magellanic Clouds are the two most prominent satellites of the Milky Way, visible to the naked eye from the southern hemisphere. The Large Magellanic Cloud contains several billion stars and is located at a distance of about 160,000 light-years. The gravitational interaction between the Magellanic Clouds and the Milky Way has created the Magellanic Stream, a giant ribbon of neutral hydrogen stretching across half the sky. This gas ring will someday fall back into the Milky Way, fueling future star formation. The Andromeda Galaxy, our nearest major galactic neighbor, is 2.5 million light-years away from us. But this distance is decreasing. Andromeda is approaching us at a speed of about 110 kilometers per second. In approximately 4.5 billion years, the two galaxies will collide. Despite the drama of this event, individual stars are unlikely to collide due to the vast distances between them. However, gravitational chaos will destroy both spiral structures, and eventually, the galaxies will merge into one large elliptical galaxy, which astronomers have already nicknamed Milkomeda. The local group of galaxies, including the Milky Way, Andromeda, the Triangulum Galaxy, and more than 50 dwarf galaxies, occupies a space about 10 million light-years across. This is our galactic neighborhood in the universe. The local group, in turn, is part of the Virgo supercluster, containing thousands of galaxies. And quite recently, astronomers determined that we belong to an even larger structure called Laniakea, a supercluster of 100,000 galaxies, stretching 500 million light-years. The chemical evolution of the Milky Way is a story of cosmic alchemy. The first stars of the galaxy consisted almost exclusively of hydrogen and helium left over from the Big Bang. But nuclear fusion inside stars created heavier elements, carbon, oxygen, iron. When massive stars exploded as supernovae, they scattered these newly created elements into interstellar space. The next generation of stars formed from enriched gas containing more heavy elements. Our Sun is a third-generation star, containing the legacy of countless preceding stellar lives. Every iron atom in your blood, every calcium atom in your bones was forged in the core of a dying star billions of years ago. We are literally made of stardust. Neutron-star mergers play a critical role in creating the heaviest elements. When two neutron stars collide, they create conditions ideal for the rapid neutron capture process, which produces elements heavier than iron, including gold, platinum, and uranium. A single such merger can create a mass of gold several times greater than Earth's mass. In 2017, astronomers first observed such an event simultaneously in gravitational waves and electromagnetic radiation, confirming this theory. The star formation rate in the Milky Way is currently about 1 to 3 solar masses per year. This may seem slow, but over 1 million years, this creates millions of new stars. However, the pace is slowing. Billions of years ago, the Milky Way was forming stars much faster. As gas is depleted and ejected from the galaxy by supernova explosions and central black hole activity, star formation is gradually fading. The galactic habitable zone is a concept describing regions of the galaxy most favorable for life. Too close to the center and intense radiation, frequent supernovae, and gravitational disturbances make long-term stability problematic. Too far on the periphery, and there are insufficient heavy elements for forming rocky planets. The Sun is located in a favorable zone, far enough from the dangers of the center, but in a region with sufficient metal enrichment for the formation of terrestrial-type planets. There are potentially billions of habitable planets in the Milky Way. The Kepler mission showed that planets are extremely common. Practically every star has a planetary system. About every fifth Sun-like star may have an Earth-sized planet in the habitable zone, where liquid water is possible. If even a tiny fraction of these planets developed life, the galaxy could abound with biospheres. The question of whether we are alone in the universe may soon receive an answer. The Fermi paradox asks, if alien life is probable, where is everyone? The galaxy is 13 billion years old, more than enough time for technological civilizations to develop and even to colonize the entire galaxy. Proposed solutions range from life being extremely rare to advanced civilizations destroying themselves, or that they are simply not interested in contact. The silence of space remains one of the most profound mysteries. The future of the Milky Way is fascinating. In 2.5 billion years, the Large Magellanic Cloud may collide with our galaxy, potentially awakening the central black hole and triggering a burst of star formation. Then will follow the collision with Andromeda. After billions of years of chaotic interaction, the galaxies will merge into Milkomeda, a large elliptical galaxy. Most of the gas will be consumed during intense bursts of star formation or ejected from the system, leading to a decline in new star births. In the distant future, trillions of years from now, Milkomeda will become an island in the expanding universe. Cosmological expansion, accelerated by dark energy, will carry other galaxies beyond the cosmic event horizon. Future astronomers in Milkomeda will see a galaxy floating in an apparently empty universe without any signs of other galaxies existing. The irony is that we live in a golden age of astronomy, when the universe is still visible in all its glory. Star formation in Milky will eventually cease. In 100 trillion years, the last star will ignite in the galaxy. By that time, only long-lived red dwarfs, white dwarfs, neutron stars, and black holes will remain. The galaxy will enter the degenerate era, a dark period illuminated only by occasional flashes when white dwarfs collide or matter falls into black holes. In the unimaginably distant future, in 10 to the 100th power years, even black holes will evaporate through Hawking radiation. Matter organized into galactic structures will ultimately return to dispersed radiation and elementary particles. This is the heat death of the universe, a state of maximum entropy where no further evolution can occur. But now, in the present cosmic time, the Milky Way is alive. It is a dynamic, evolving system, continuously recycling matter through cycles of stellar birth and death. Every clear night sky offers us a view of this magnificent structure from within. The pale band of light crossing the sky is the combined light of billions of stars, so distant that they merge into a luminous haze. Our understanding of the Milky Way has evolved dramatically. Ancient cultures saw in it the milk of a goddess, a celestial river, or a road of souls. Only in the 20th century did we understand that it is a spiral galaxy, one of billions in the universe, and that our sun is just one star among hundreds of billions. This realization was simultaneously humbling and elevating. We are tiny in the cosmic scheme, but we are also part of something incredibly grand. The European Space Agency's Gaia spacecraft has revolutionized our knowledge of the galaxy, precisely measuring the positions, distances, and motions of more than 1 billion stars. These data revealed wave-like patterns in stellar motions, evidence of past galactic collisions, the structure of spiral arms, and much more. We are creating the most detailed three-dimensional map of our galactic home. The Milky Way is not just a scientific object of study, but also a source of inspiration, wonder, and philosophical reflection. It reminds us of our place in the universe, of our connection with the cosmos, that we are the universe knowing itself. Within each of us are atoms forged in stars that died long before Earth was born. We are literally made from the galaxy. In this magnificent spiral of stars, gas, and mystery is our home. A small blue dot rotating around an ordinary star, inhabited by a form of life curious enough to look up and ask questions. The Milky Way is our galaxy, our heritage, our future, and our endless mystery awaiting exploration.